So with this problem, there are multiple variations on this fence problem, but the general idea is the same, and actually the general idea is the same as most of the other min-max problems in this section, or in math in general. So Monique has a creek or crick, however you want to pronounce it, depends on where you're from, in her backyard. She wants to use some fencing that she has to create some rectangular region that's fenced off. She has 340 feet of fence in this particular example. And the creek is, or crick, or whatever you want to call it, the creek is going to be essentially one part of the enclosure. It's going to either keep things out or in whatever, it depends on what you're housing or fencing in or corralling. And she's going to use 340, and she wants to get the largest area possible. And so if it's a rectangle, we know that this dimension can be represented as the variable x. This one can be represented as y. And then, of course, if this left side is x, this right side will be x as well, which means the perimeter of our fence would be 2x, or excuse me, the perimeter of our rectangular region would be 2x plus 2y. But if we're only worried about the portion that's fenced in, this portion, that's not a good color for what I was trying to do. Highlight this. If we're only concerned about that, then my fenced in area is going to be 2x plus y with regard to the fence that I'm using. And so that perimeter must be equal the maximum amount of fence, 340 feet. Okay? Now, how do we calculate the area of that region or her corral? Area is going to be equal to x times y. It's a rectangle, base times height. So, but we have the system of equations, and we really want to turn this into a minimum maximum problem. So we're going to take the first equation. Let's make this a little bigger as well. We're going to take this first equation, and we're going to solve it for y, and then substitute. Could do it the other way around, but it's less complicated this way. So I'm going to subtract 2x from both sides. So I'm going to end up with y equals negative 2x plus 340. Okay? Now I'm going to take this equation and I'm going to substitute it into this equation so that I have the area of my corral equal to x times negative 2x plus 340. Distribute the x and get a equals negative 2x squared plus 340x. Now, there are two ways to do this. I'm going to show you how to complete the square, and I believe in my heart that if you learn how to complete the square effectively, then you will be better off downstream working in pre-calculus, calculus, etc., etc. It'll help you, it'll give you insight as to how these numbers interact when you're distributing and factoring, etc., etc. So I'm going to do that first. If you're not interested, scrub ahead. So what I'm going to first do is factor negative 2 from both of those terms to get the following. Negative 2, I'm going to be left with the x squared minus 170x. And I'm going to leave a bunch of space there. And then I'm going to do the following. I'm going to, just like I normally complete the square, I'm going to take 170 and divide it by 2, and then I'm going to square it and add it to my equation. But because I've factored out this negative 2, all of this work happens inside the parentheses. So I'm going to have my x squared minus 170x, and then I'm going to add, let's change colors, I'm going to add the square of 170 over 2. That's half of 170 squared. But so that I'm balancing my equation still, I'm going to subtract the same value. When I say balancing my equation, I guess it really doesn't look that way. What I'm doing is I'm adding and subtracting the same amount, so I've not changed my equation. That's probably a more accurate way to state it. So because these two add up to 0, I still have the same stuff. So now, x squared minus 170x plus 170 squared over 2, that's my trinomial. And then I still have this blue thing out here that I have to deal with, 170 squared over 4. Okay? I'm going to write this as my binomial squared because it's a perfect square trinomial. Negative 2. I guess I still want that to be a square bracket. So this is x minus 170 over 2, the quantity squared. And then I still have this blue thing inside the square bracket. Okay? Now, I'm going to extract that from inside the square brackets, which means I have to do this, I have to distribute this. I guess that's an easier way to think of it, or a different way to think of it. I'm going to distribute this here and distribute that there. And so I get negative 2 times the quantity x minus 170 over 2 squared. And then this blue thing becomes negative 2 times negative, so that's going to be positive, and then 2 times this thing, it's 2 divided by 4 is 1/2, so I get 170 squared over 2. This is my vertex form, so I know that the x value of my vertex is going to be x equals 170 over 2. Okay? That's the place we're going to be when I do this, the way that the book espouses, and you will probably agree that it's more direct and easier, faster, etc. If we know that my vertex is negative b over 2a, comma, and the textbook shows us this expression as something. I typically do not remember it, and most textbooks actually don't use it that way, so it's kind of odd that they do. Typically what we end up doing is many textbooks will present this idea in addition to completing the square. They'll present this idea, and then how do you find this part? You put this back into your original quadratic equation. Not the quadratic formula, the quadratic equation, figure out the y that goes with that x. In any case, we're going to figure out this x value, that is the x value for my vertex, by taking negative, and my original b was 340, right? So negative 340 over 2 times a, which is negative 2. And what we'll find is we get the same value here. We get negative 340 divided by negative 4. And so both of these numbers are divisible by 2. Actually, 170 is divisible by 2 as well, so I don't know why I'm messing around with that 170 over 2. It's 85, right? And so this becomes 85. Okay? So now that we have that x value for our vertex, we have, from both of these methods, we have v equals 85 comma whatever. This becomes not important. If I was asking for the vertex of the parabola, then of course it would be important. We would take our original equation and substitute 85 in for x and figure out what y was. But in this case it would have been the area. But this problem is not asking that. The problem is asking how long do I make these dimensions in order to have this fence that has a total length of 340 feet. So now we know that it's going to be 85 feet, 85 feet, 85 feet by 170 feet. So I reviewed the question. In fact, they did not want the dimensions. They actually wanted us to calculate the area. And so the area of this corral, this region here, would be equal to 85 times 170, which is 14,450 square feet.